In notes number 5, we're going to talk about the triangle proportionality theorems. And the triangle proportionality theorem is if we have a line that's parallel to one side of a triangle and it intersects the other two sides, then it divides up those other two sides proportionally. So if you notice how I color-coded the ratio and proportion over here, that we would have RT over TQ and then RU over US. So what's nice about this is if these two sides are parallel, we don't have to separate out what the two triangles are, how I've done on the previous notes of drawing the two separate triangles. So the converse of that is if we have a line that divides the two sides of a triangle proportionally, then it is parallel to that third side. So same thing happens here, is if we know that these different sides, if we set up a ratio and they are proportional to each other, then that tells it that these two lines are parallel to each other. So in number 1, you can see that QS is parallel to UT, and because of that we can set up our corresponding sides that are proportional to each other. And this is how your proportion would go. So QR would be on top. We don't know what that value is. UQ then could be underneath it. And then for the other side of your triangle, RS over ST. So when we cross multiply, we would get a 36 equals 6 times QR, or RQ. And if we divide, we would get RQ. The length of that is going to be 6. So if that side is 6, then these are proportional to each other. On number 2, we want to show that we want to explain why the shelf is not going to be parallel to the floor. So this BD line right here, why is that not parallel to the floor? Remember that with the converse of the triangle proportionality theorem is that if we have the sides that are proportional to each other, then we can say that they are parallel, that those two sides or two lines are parallel to each other. So this is basically saying why is it not parallel. So we want to show that the ratios are not the same. So we start off not knowing if they are the same, so 27 over 33, and then CD would be 44 over 25. When we reduce those, this first one can be reduced to 9 over 11, but the second one it would be the same. So these are different ratios. Because the ratios are not congruent to each other, we know that BD is not parallel to AE. Sometimes you're going to have a picture that doesn't necessarily make a triangle, but you do have parallel lines. So if we have 3 parallel sets of lines that intersect 2 transversal lines, then they intersect the transversals proportionally. And you can see that in my picture over here. So UW would be over WY, and then VX over XZ. So those ratios would be proportional or equal to each other. So we can use that now on our next picture. So we know that if the two streets are parallel to each other, that we can set up these corresponding pieces to find the missing piece. So we know that the 2.1 would be over 2.8, that should be equal to the missing piece, so that would be X, my blue part, over 2.4. So I'm going to solve this now for the blue part. Actually, let's have you solve that. So go ahead and find what the length from City Hall to First Street is going to be with my X. When you cross multiply, you should end up with X equals 1.8. So knowing that X is 1.8 is great, but we want to know what's the distance from City Hall, right here, all the way to 2nd Street along Cedar Road. So we want the whole distance all the way along there. So we have to add those pieces together. So 1.8 plus the 2.4 is the answer that we are looking for, and that would be 4.2 miles. Just like we saw before with the shoe rack, if we want to verify that MN and QR are parallel to each other, then we need to show that the ratios are congruent to each other. First, before we do that, we need to know what is the length of PM. So if we take 9 minus 2.7, we get 6.3. So that's what that little piece is going to be. And then same thing with your 10 minus the 3, we end up with 7. So this little piece is 7. So I can do my 6.3 over 2.7. And then we want to set up the ratio of PN. So that would be 7 over my NR in orange, and we want to see if that ratio is also the same. So if you notice, this first ratio, or the second one, will just say 7/3. This first one, though, does reduce to 7/3, so they are proportional. So that means that MN is parallel to QR. Now we're going to do the same thing for number 5 and determine if AB is parallel to CD. So I want you now to fill that out, and I want you to tell me yes or no, are they parallel to each other and why? If you set it up just like I did, you would have 16/10, which reduces down to 8/5, and 28/20, that reduces down to 7/5. You can see they are not the same ratio, which means the sides are not proportional. So AB is not parallel to side CD.